Okay, find the differential equation for circles tangent to the x-axis. So, gagawin is, imagine mo siya, i-draw mo muna. Yun, circles, tapos ito yung point of tangency niya, yung pinaka-x-axis. Kita naman natin, ito yung circle, tapos nag-touch siya sa x-axis, yun yung point of tangency niya. At ang center ng circle is h, k. Pero, dito pa lang, kaya niya sinabi na circles tangent to the x-axis para magkaroon ka ng hint kung anong radius. Kasi kapag wala kang ano ng radius mo, tatlo yung arbitrary constant mo, which is medyo mahirap-hirap. So, tingnan mo na. Kita mo naman na k units, di ba h, k? K units automatically yung radius. Kahit lumaki pa ng lumaki yan, halimbawa, tumaas pa ng konti, lumaki pa. Yung radius mo pa rin is equals to k. So, k units. So, let r is equals to k. Okay? So, gamitin mo na yung standard form. X minus h squared plus y minus k squared is equals to r squared. Mark this as equation 1. Then, is substitute mo na yung k squared yung sa r squared. Naging k squared. Okay? So, so ito na. Derive mo na siya. 2x minus h plus 2y minus k, y prime is equals to 0. Okay, lowest term mo, times mo ng 1/2 both sides, magiging x minus h plus y minus k, y prime. Mark this as equation 2. Okay, so proceed to second derivative because we do have two arbitrary constants. So derivative of x minus h is 1, derivative of 1 minus k, y prime is, this is a product rule. Let y minus k is equals to u, and let y prime let v. So u dv, u copy u times the derivative of v, y double prime plus copy y prime, hindi mali, plus v du, copy y prime times the derivative of y minus k is y prime. So y prime times y prime is y prime squared. Okay, so equals to 0. Now, as you can see, there are no arbitrary constants left except for k. So, you can isolate y minus k to plug it in sa mamaya sa next step. So, solve for y minus k. So, 1, lipat sa kabila, it would be a negative 1. And y prime squared, it would be a negative y prime squared, negative of factor out, I factored out negative 1. So, and divide by y double prime both sides. So, matatanggal y double prime, this would have y double prime. So, the value of y minus k is negative 1 times 1 plus y prime squared over y double prime. But, we do have k squared right here. So, using this equation, you can further solve for k. And, I forgot to mention earlier that you should mark this as equation 3. Okay, now, we can solve for k. So, we just transpose this to the other side, it will be negative y, but I don't want a negative value. As you can see, there are negative values all over the place. So, we can switch it both sides or transpose those variables on their opposite sides. We will arrive at positive k, positive. Okay, mark this as equation 4. Now, here's the exciting part. The solved values for k, x minus h, y minus k would be soon used in the next step. But for now, we need to solve for x minus h. Okay, x minus h, so as you can see, plug in the equation 3 inside equation 2. Okay, so we substitute y minus k by this solved equation. So x minus h plus y minus k, negative, ito yung value ng y minus k is negative 1 times 1 plus y prime squared over y double prime times y prime because of this. Okay, because of this. So we can solve for x minus h, we just transpose it to the other side, the negative would be a positive value. Okay, mark this as equation 5. Now, the most exciting part is when we are going to plug in the solved values for x minus h, y minus k, and k. It would be the equations 5, 4, and 3, and we will put it inside equation 1. So ito yung x minus h, y minus k, r squared. So 1 plus y squared over y double prime times y prime squared plus negative 1 times 1 plus y prime squared over y double prime squared is equals to 1 plus y prime squared over y double prime plus y squared. So we are going to further simplify this. Okay, just copy it right there. Now we do know that there are two variables that are the same on this equation right here, so we can factor out 1 plus y prime squared, as you can see. But this one is a negative value, but due to the power of raised to 2 it would become positive, so factor out, we will be left out by y prime times y prime plus 1, because we factor out this value right there. Okay, so it would be 1 plus y prime squared times y prime squared times y prime squared plus 1 over y double prime squared. So that is the equation. On the left hand side. However, in the right hand side, we do have the k squared, which is this. We just left it the way it is for now, for a moment. But and the next step is we are going to multiply y double prime squared both sides to cancel the denominator on the left hand side of the equation. Then we will be left out with 1 plus y prime squared to the third power. It's to the third power because there is the values inside this parentheses are just the same, and it is raised to power 1, raised to power this is raised to power 2, and this is raised to power 1. So power rule, okay, it will become 3. It would just add up. This one was cancelled and the other one was multiplied by y double prime squared. So this part of the equation is, I think it's quite simplified. Okay, this was simplified, and we need to simplify this. It's just a simple algebra. Okay, this is raised to second power, this is raised to second power. We can just multiply it. We don't need to expand it further. So y double prime squared, but inside this is square. So the technique is just what do you call this? Just ignore the powers because they were just the same. So y double prime cancel. Y times y double prime, then copy the power. Then final answer, that is the final answer, 1 plus y prime squared to the third quantity, 1 plus y 1 prime squared quantity to the third power is equals to 1 plus y prime squared plus y double prime to the quantity to the second power. Okay, final answer.